have done another crystal ball gazing of where things go. And I thought, okay, so maybe the future is 3D printing in metal. And the reason for that is I realized that you can do with 3D printing a lot of shapes, complicated geometries that you cannot do with normal metal working techniques like machining and forging and all that stuff.
You are listening to Service Course by the Cycling Podcast with Lizzy Banks and Tom Whalley.
I've kind of been blown away by how far time trial tech has come in the last few years. It used to be a relatively, I don't want to say it was ever a level playing field, but the tech and equipment involved in time trialing has advanced so much. I mean, you see today with Dennis and Ganna up front, and one thing that I really picked up on both those riders is the 3D printed handlebars and Ganna's, whether you call them the skis or the extensions. It's incredible. I mean, it's crazy how, far it is from the base bar of his time trial bar up to where his hands are resting. And I know that there's a lot of rules in place from the UCI as far as regulations as angles, the tip of the bars to the saddle. And there's all sorts of, rules that your bike has to fit within the jig at the start line. But it's crazy to see with 3D printing just how far they can push those limits. And there's a rule that your elbow pads have to be, I believe it's 10 centimeters. There can't be a 10 centimeter gap between your elbow pads and the end of the extension. And I've noticed today on Ganna's bike that his elbows aren't even resting in the pad. It's actually more of his forearm, just so he's within that regulation, but still allows him to get that position. And there's all sorts of kind of little tricks that people play to meet that standard. And it's fascinating to see how far technology has come and to see a rider like Ganna in such an incredible position for such a big guy. It looks like he could probably ride a bigger frame size, but with the ability to have a 3D printed bar, he's really able to maximize his aero position.
Oh, thank you, Ian Boswell, for what you said on the main podcast the other week. It's almost as though you knew what me and Lizzy were doing on Service Course this month.
Perhaps he's just trying to sneak his way into a job on the best podcast with the Cycling Podcast, Tom.
Maybe that's the case. So we're talking this month about 3D printing, and we've seen a lot of it if you've been watching the Giro, because Ganna, who probably been man of the match for the Giro, I would say. Wouldn't you, Lizzy, I reckon? I
mean, he's done all right with 3 stage wins. I mean,
it's not bad, is it?
1/7 of all stage wins is a pretty good record. I wish it was. Well, I guess I got 1/8 on our Giro Rosa. No, 1/9. Sorry. So yeah, I can't quite equal Ganna, but it's a pretty impressive record.
Sorry to interrupt. Just got a live corrections corner. Of course, it was 4 stages that Ganna won. I'll be back with another one of these later. And he owes a lot of it. Well, I mean, he owes most of it to his legs, probably, but 3D printing has played a role. So we're going to talk about that in this month's pod. But first of all, I want to catch up with you, Lizzy. It's been a while. It's been a dramatic while since we've spoken last.
It has been a dramatic while, and if you forgot to ask where we were, Tom, and...
Oh, yeah, no, we should do that. Well, I'm in the shed as usual, Lizzy. You're in a sort of a it looks like a glass cage.
I'm in the car, Tom. So we've got builders in our house at the moment, and it's so noisy that I've come out to sit in the car because the local lockdown restrictions where I live in Sheffield mean that you can't go indoors in anybody else's property. So yeah, I'm sitting in the car. So it's lashing with rain and blowing a gale. So if you hear some strange noises, that'll be why.
Well, at least you're very much on brand. You've got a Cycling Podcast t-shirt on, the Cycling Podcast mug as well. Yeah,
that's true. Got my Stacey Schneider mug. I've got my Pedaler de Charme t-shirt that I won at the 2019 Women's Tour. So yeah, all on brand. And actually, I brought loads of layers, so I thought it was going to be freezing cold. And it's a bit of a sweat box in here, so I had to take all my clothes off. So good thing this is a podcast.
But Lizzy, honestly, how have you been? Because it must have been a bit of a stressful time for you. For those who don't know, I mean, I'm pretty sure everyone knows, but your team... early in the year, it was in jeopardy. It looked like it had been saved, and then that turned out to not be true, and the team has folded since. So where are we now then, Lizzy?
Well, it has been, an incredibly stressful month. Thankfully, now I'm happy to say I've signed a contract with a new team, and I'm actually really excited about the team that I'm going to, and the things that we can do together next year. But obviously the situation in which I'm changing teams is not ideal, and not at all what I imagined. And I'm happy to say that all the riders on my team that were in contract with the team for next year, I think they've all found a contract now with different teams. I'm not sure whether everybody's actually signed, because sometimes these things can take a while to, actually get signed. But yeah, so the news will go out on the 11th of November, so you won't have too long to wait. But yeah, I mean, it's just been an absolutely crazy period. It's been very, very stressful. It's been quite eye-opening to try and negotiate at this late stage. But I have to say, I'm pretty grateful to have a job at all. I mean, there are a lot of people around the world out of cycling who are out of jobs, and also within cycling on the men's side, I think there's about 100 guys out of jobs. So yeah, it's incredibly stressful, but I'm so grateful to have a job now. And it's been not been the ideal off season for me, really. It's not been kind of the relaxing off season spent on the beach that you would like to have, but I'm going to spend the next week walking in the hills and de-stressing, and then get back to training in another week or so.
Well, it's been. I mean, before we did this call, we were chatting off air about what's happened and how it's been handled. And I mean, for me, it's a fascinating story, and I hope that one day we can tell the story, the implications for all the riders, the teams, what people had to go through to find jobs. It would be a fascinating story, and it would be really, really eye-opening. And for those of you who are asking, by the way, stop asking Lizzy what team she's signing for, because she won't even tell me.
Yeah, I mean, I will tell you when I can tell you. So, you're not going to have long to wait. 11th of November is when the news is coming out. And if you want to know the real story about what went on behind the scenes, then you're going to have to wait for the book at the end of 2021.
That will be a fascinating book, Lizzy. Are you writing a book? Is that actually happening?
You have to wait and see. I don't know. I've got a lot of stories to tell, so maybe one day. But I think right now I'm just going to have a little holiday and relax and turn my internet off and ignore the world for the next week, I think.
Go very, very easy on yourself, Lizzy. With your new team, though, 3D printed parts on your bike, Lizzy?
Well, you'll have to wait and see. I do not want to give the game away. We'll have to talk about that in the next episode, Tom. But I mean, 3D printed parts are definitely becoming a staple component of, well, every bike in the pro peloton now. You see more often than not 3D printed parts on the time trial bikes. It's not so common on the road bike, really, because road bikes are a bit more standard, but perhaps we will see it more with kind of integrated handlebars, and then you've got specific size of handlebars because every rider is different, and so they all want a different geometry, and so perhaps we'll see that more. But I think I mean, you have to look at the bikes at World Championships. All of the winning bikes had, well, the two winning bikes, Anna van der Breggen and Filippo Ganna, both had custom 3D printed bars on there. So, and I think later you're going to talk to the maker of Ganna's bars, aren't you?
Well, we're going to talk to Dimitris Katsanis, who makes bars for pretty much everyone at Ineos, and we're also going to be speaking to a brand called Hexr, who do 3D printed helmets. That's right, isn't it, Lizzy?
Yeah, it's an amazing company, actually. It's the only brand in the world doing 3D printed helmets at the moment, so it's pretty cool.
Well, before we get into the cycling implications of 3D printing, I wanted to get an overview of the actual technology that we're talking about, sort of idiot's guide. I spoke to Ian Maskery. He's a research fellow in the Faculty of Engineering at the University of Nottingham. He's part of the Additive Manufacturing Research Group. Let's hear a bit from him now. So this is a real idiot's question, right? But if I'm printing in regular 2D printing, I'm literally printing ink onto a piece of paper, right? It's onto one surface. 3D printing, I understand, once you start printing, you can print onto the component or whatever it is you've built. But that first thing that you print, what is there a framework? What are you printing onto for when you start the process?
Yeah, I mean, there's lots of different printing processes, all in the umbrella term of 3D printing. We've got there is some depth there. What you're talking about is like deposition processes where you start off with some flat layer and then you start sort of extruding some material onto it. And then what happens is that that layer moves down, you extrude again, your layer moves down, you extrude again. And that's sort of like, that's what most people think of as 3D printing. And that's exactly the sort of 3D version of what you've just described, like the 2D printing process. And in that case, all you're printing onto is a flat substrate, like a glass substrate or something that you just take your part off afterwards, and you've got your 3D part, and that's it. But there are lots of other processes besides that. One which is probably most relevant to cycling is what's called laser powder bed fusion, and this is a process where instead of depositing material, like instead of extruding some material out of a nozzle, what you're doing is you've got this big bed of metal powder, which is just sitting there, sort of like sand, right? It's like really small particles of metal, often aluminium and titanium, but we do steels and Inconel and all this sort of stuff. And you use a laser or an electron beam, a focused electron beam, but more often a laser. Use a laser to sort of melt the regions of metal powder that you want to become solid. So the energy source, the laser, melts the metal powder in a small volume. It solidifies, it becomes the solid part, and you just keep on doing that. You move the layer down and down and down. You use the laser to melt the powder bed, and then you can just brush off all the excess metal powder at the end. And what you're left with is the solidified version according to whatever you've designed.
So, I mean, we're very early in the development of 3D printing. It's still a relatively new technology.
Well, it's been,
I mean, or is it? I mean,
a very long time. It's been around since, as long as I've been alive. Certainly, like the early days of 3D printing, even, sort of the processes that we think of now. You can buy a desktop system and print off toys in your living room, whatever. I mean, they have their origin sort of nearly 30 years ago, when they were originally sort of devised as a way of making design easier, because typically, how do you designing components is quite difficult. You start off with drawings, or at least you used to, and then you would move into 3D graphics as well. Then you would end up with sort of a 3D representation of what you wanted to make, and then you got to the difficult bit, because the next step, usually for manufacturing something, before 3D printing really existed, the next step was to get some prototypes made of that part that you've designed on your computer. So you're going to go from this digital object which you can't touch or see or anything like that, and you're going to have to build some prototypes, and that usually means getting a factory to agree to make them, and that's very, very expensive. Because if you've never made something before, if it's a unique shape, there are tooling costs and all sorts of costs, and you might have to have lots of them. But the outlay, the expense for a designer and manufacturer would be quite high, just to see the part that they've designed before you could even say whether or not you're happy with it. So this process emerged, 3D printing processes emerged as part of rapid prototyping. So this was meant to allow you to design something on your computer, print it out, and you have a prototype where you can say, oh, actually, I want that bit to be bigger and it doesn't fit right, and you need to make some changes. And then you can do this sort of iterative loop of designing, printing, testing, designing, printing, testing. You get your design completely finished, and then you don't need to do this sort of costly prototyping. You can just say, well, this is it. This is the finished article. I'm going to send it off to the manufacturers to get 100,000 of these things made. So that's how it started, and that started decades ago. Probably the thing that's changed is that we've increasingly seen that the sorts of printers that used to be used for that weren't great, right? They were relatively low resolution, and there were limitations, and usually only a handful of materials like plastics. What's changed is that middle section has now become huge, and the resolution, the material properties, the material selection have all grown to such a great extent that it's a viable manufacturing option by itself. So it's no longer seen as just this like link in the chain, this rapid prototyping link in the chain to cut costs down and get your design right. Now you can actually think of these printing processes as being the final step, the manufacturing step, without needing to go and do the tooling and so forth.
Did you learn a lot from that, Lizzy? You feeling a bit smarter? I
did. Well, Tom has taken the gems of information from that, but actually I listened to the full interview with him, and I learned so much about kind of aerospace and all the different technologies and applications for 3D printing. And I guess that it's been around for a lot longer than I realised. I guess it's probably been around my whole lifetime, but you would never have known. You only really kind of heard about 3D printing, I would say, in the last 10 years. It's kind of blown up, and over the last 5 years or so, it's kind of a common term. If you say 3D printing to anybody on the street, they'll know what you're talking about. Whereas maybe 10 years ago, you'd have mentioned the idea of 3D printing and then what on earth's that? Like, how does that work? Whereas, it's applied in technology kind of across the board now. But yeah, it's super interesting. And I think we are going to see it a lot more in cycling. And I think that, cycling is the perfect breeding ground for 3D printing technologies, really. I mean, we already saw last episode that we did saddles?
Yes, it was, yeah. Yeah, just me interrupting again. It wasn't last month, was it? It was the month before. That's right.
Yeah, we saw last episode that a number of saddle companies are moving across to 3D printing, and it's an easy-ish way to create a prototype, and actually we've seen that the comfort factor is a lot higher in 3D printed saddles, and obviously at the moment there is a huge cost implication, but hopefully as 3D printed items become more of the norm, and the technology and the materials will become cheaper and it'll become more accessible for everybody.
Well, talking about cycling then, if you want to know how to win a time trial, it seems that you do need 3D printed bars these days. I spoke with Dimitris Katsanis. He is the founder and CEO of Metron. He's been involved in cycling for a long, long time, as you'll hear in this interview. He was part of the Secret Squirrel Club, working with Team GB to design the bikes they use in the Olympics. Previously, he's also designed his own frames, and I'd recommend Google Metron bike Chris Hoy, and you will find an incredible image of one of his track bikes from back in the day, and we'll put that on our socials too. Katsanis creates parts not just for bikes but for all kinds of sports where aerodynamics play a key role, and obviously handlebars, as we said, they're a big thing in 3D printing at the moment, as we heard Ian Boswell mention at the top of the show. And I spoke to Dimitris during the Tour de France, and he started by telling me the riders who he's been making bars for.
We actually did a few new bars this year to start with, actually for quite a few people. We've done like a new version for Froome and Geraint Thomas. They are out. Then we did one for Carapaz. He crashed. Bernal has something that we actually did for him since last year. He was about to race with this, but he's not doing very well nowadays. He cracked the other day, so he's not going for the win anymore. But pretty much the entire team, they will have bars that we made. Actually, what's his name? Pavel
Civica.
He has one which is like again a very recent one, which is that's actually a very light one. We've done a version which it was like specifically designed for mountain time trials and so on. And the weight is, to give you an idea, the full carbon bar, the standard carbon bar with the aluminium bits for the arm pads, and the extensions are also carbon, but there are some aluminium parts on. The full extension, the full bar of that, including the computer arm and some covers and stuff like this, is around 820 grams, if I remember correctly, which is more or less what all these time trial bars they are. By the time you include all the components on, like the computer arm and so on. And the latest version that we've done for Sivakov, in fact, it is 520. So it's like we're talking about 300 and something grams lighter, and that's including the computer arm. So this was actually really good because we managed to put together everything we know to make it both light and aero. So it's all like form fitting and all that, but also we've done every little trick we know to save a lot of weight. And if you think about it, when you talk about 500 grams for what is like in effect a stem, a base bar, and the extensions of the computer arm, this is actually going to the range of like what you have for, a normal carbon one-piece stem and bar is around 400 grams. And that one is about 100 grams heavier, including all the extensions and the arm caps and the computer arms and all that. So, yeah.
Well, it's fascinating.
That's a nice piece of engineering.
Well, I'm fascinated by the work you do. I want to get back to more sort of 3D printed stuff on bikes, but you yourself, how long have you been involved in sport?
I was cycling myself. I was all right. I wasn't world class. So I was cycling myself. I raced I think I raced World Championship on the track once in 1987. My God, this is a long time ago.
Pretty good credentials. That's pretty good.
Yeah. I raced it. I didn't win it. But then, actually my first degree is in sports science. And then after that, I thought, I'll probably go out and study engineering because I always liked engineering. And in the beginning, I went on and I studied composites engineering, carbon fiber and all that stuff. I was actually making bikes before that. I started making bikes in 1989. I think it was the first time I made the first bike. I was actually racing till about 91. There was a short period that I was holding the sprint national record for Greece. It wasn't any fantastic time. I think it was 10.9, if I remember correctly, which 10.9, even, I don't know, juniors, they're going much faster than this nowadays. And then I was a coach in cycling for a couple of years. With the Greek national team, and then after that I decided I'm going to go and study engineering. And I was cycling a bit, and then the more I got involved into cycling as a designer, the less I ride myself, which is not very good, really.
Yeah, I see that.
Yeah.
But your interest is beyond just cycling, though, isn't it? I mean, you turn your skills to sport in general, don't you?
We did quite a lot of stuff that they have to do with other sports, like. I started doing quite a lot of work with things like UK Sport for cycling to start with. But then through UK Sport, did quite a lot of stuff, everything that has to do from sailing and bobsleigh and a bit with snowboarding and I can't remember what else, wheelchair racing, I remember probably 2 or 3 others, which I cannot remember at this moment in time. So it's quite a lot of different sports. Anything that it has like any kind of engineering input, did quite a lot of that. And on the cycling front, it's not only really the bike that I dealt with. I dealt everything from helmets and skin suits and shoes and, you name it. Frames, forks, handlebars, wheels, cranks. I think the only thing I haven't done is tires and chain. I think I've done everything else.
So talk to me about 3D printing then. As a technology, what is the advantages then of having a 3D printed bars?
Actually, it's quite interesting. I'll give you a bit of background. Like in the early 90s, when I decided that sports science won't take me far, I thought I'll go and study engineering. What I did at the time is I did a bit of, crystal ball gazing, and I thought what is the future? And at that time, we're talking about 92, 93 now. I thought the future is composites, carbon fiber. So I went on and I studied composites and so on. Then when I started working with British Cycling, I worked with British Cycling since 2002. So we're talking about 18 years. And through that, I got involved with quite a lot of what it was called at the time rapid prototyping, 3D printing in plastic. So we made a lot of stuff that they're going on to wind tunnel testing, everything from helmets to handlebars to prototype components and all sorts. So that was 3D printing in plastic. And that actually started giving me the understanding of what you can do with the technology. So I think that I designed the first 3D printed plastic bits in 2005, something like that. And then I started using it for other things like jigs and fixtures and actual parts that they even raced in the Olympics before anybody knew anything about this. And then I realized, I thought, like, why you can do it in plastic and you cannot do it in metal? And I realized around 2009, 2010 that the technology was not quite there yet. It was still developing. So at that time, then I decided I'll wait and see how things are going to go. And then it was around after 2012 when the Olympics for London came and gone. I said, I have done another crystal ball gazing of where things go. And I thought, okay, so maybe the future is 3D printing in metal. And the reason for that is I realized that you can do with 3D printing a lot of shapes, complicated geometries that you cannot do with normal metal working techniques like machining and forging and all that stuff. Remember, I come from a composites background, so in effect, the composites background I found very useful because with composites, you do all these organic shapes and different thicknesses and different orientations of the material and all that, which for metal, this is not really what you're doing. For metal is usually you have very boxy shapes, very well-defined straight lines, radii and all that stuff. So then I found it that the composites experience works very well with 3D printing because you can keep these organic shapes and aerodynamic shapes and shapes that one is blending into the other and so on in a nice smooth way, which you can do quite easily with composites, but not easy enough with metal. So I found that very useful. And then I also found that it can give you extra design freedom that you're simply not getting with any other metal working techniques. And also, I also saw that you can transfer a lot of the knowledge from the composites onto 3D printing, like internal structures. Like in composites, it's quite common that you may have like two carbon fiber skins, and you may have a core of honeycomb or foam or something like this in between. And you can do similar things with 3D printing. You can have like two external skins, like it can be, the upper and the lower bit of the handlebar, of the aero section of the handlebar. So you have the cross section, and then in between you can put things to support those skins. So 3D printing can actually do that, and you can do complicated shapes. Like if you were telling me 3 years ago that you will be making a titanium or a metal in general, titanium handlebar, that it will be lighter than the equivalent carbon, I will tell you, no way. Just no way. No, the mechanical properties are just not there. You just cannot do it. But then by using the capability of the process, you can do things that they will be like, you literally take all the material away from where you don't need it and you put it only where you need it. You can have internal structure to support like very thin wall structures like aerodynamic shapes and stuff like this. And the other massive thing that is giving you is it gives you the opportunity to do what is called mass customization. You can make things made to measure. Very much like, in the old days, you will hear Eddie Merckx or any of these great big names that their frames were made to the millimeter of the length of the tubes. And it was custom made for the specific rider. Then when mass production of carbon frames came, you could only have so many different sizes, which actually means that, if this doesn't fit you, this may fit you. Some manufacturers, they're going on and they're doing it in many sizes, like Pinarello, I think they have 13 or 14 sizes. But other manufacturers, they may only have 5 sizes. And if you want something in between, half. getting either this or that. But then again, to make a custom-made carbon fiber frame or a custom-made carbon fiber part, it's not impossible, but it's difficult. Especially it is difficult if you want to combine lightweight, aerodynamic, and custom. Whereas with the 3D printing, you can do all this. You can do the lightweight by using computer simulation for the strength, finite element analysis is called FEA. And so you can do that, and you can run every design that you do within certain limits, of course. You can run it through the analysis to tell you, is it strong enough? You can do CFD, the aerodynamics analysis to see if it is okay for aerodynamics. And you can also make it to the specific rider requirements in terms of size and where they want their hands to be and all that stuff. So in effect, what we do quite a few times with this, we let the riders find their own position using normal equipment, and then we make something just for their own geometry. And we always had a significant increase in performance in terms of aerodynamics, because then you can integrate the rider shape with the shape of the components that are designed for them. Again, it goes back to the idea that you have a tailor-made frame as it used to be in the 60s, 70s, and 80s, maybe even up to the 90s. And but now it's not only the size, it is also the size and the aerodynamics and the strength and stiffness we can tailor-make.
It's fascinating. There's loads of stuff I want to pick up on there. One of the things I'm particularly interested in, I was reading about the use of titanium, and I'm a big fan of titanium. I ride a titanium frame anyway. I love the look of the material.
All right, okay.
I love I've got a carbon frame, of course, and I've got an aluminium, but I've got a beautiful titanium Lightspeed. But I was reading about the use of titanium in 3D printing. So is that a material? I mean, with the current batch of stuff you've got in the Tour de France, is titanium the material you're working with now?
Yeah, definitely. All the handlebars we do, they're all titanium.
Wow.
All of them, they're all titanium. To give you an idea, the main reason behind this is in the current state of the art, although things are changing, I'll tell you about the changing a bit later on. In the current state of the art, titanium as a material, it is the material of choice if you want a good combination of strength and stiffness and manufacturing ability for 3D printing. Many people, they say aluminium is lighter, why don't you use aluminium? The main reason why we don't use aluminium so far, although this is about to change, we don't use aluminium so far mainly because the aluminium grade that you can get for 3D printing, it is actually a medium to low grade material. I'm not gonna bother you with the numbers, but think of it that if you have most aluminium components in the cycling industry, they are made of a material called 6061, which is like a medium grade alloy, and a number of very high-end parts that were made out of 7075 aluminum grade, which is like a really high-grade alloy. The 3D printing, the material you're getting for 3D printing in aluminum nowadays, it is actually significantly lower strength even than 6061. So the downside of this is, yes, you can make complex shapes, but the strength and stiffness of the material is actually pretty low. So if you want to make a light, strong, stiff, aerodynamic part, you cannot really do it in aluminum. Titanium today is the state of the art. If you want something strong and stiff and complex, there is an aluminium grade that is coming up that it was designed and developed by Airbus, which is called Scalm alloy. You will hear a lot about this in the future, but this is just about coming out of the aerospace industry. You know, we want or not, a lot of these things, even the titanium. The common titanium grade used is what we call titanium 6-4, which is titanium 6 aluminum 4 vanadium, which is actually an aerospace grade material. And this aluminum that I'm talking about, that is just about coming out of the aerospace industry, from Airbus. It is again an aerospace grade aluminium. So now that this starts coming out of the aircraft industry, it is going to be the next one that is going to make good aluminium parts, because titanium is great for a number of applications. There are other applications that titanium is probably not quite good enough. No, it's not good enough. You can do other things with other materials. And there are some other exciting bits that we're working on, which is like what is called metal matrix composite, which is actually, you can have aluminium or titanium, and you can have in that some ceramic particles, and usually silicon carbide or aluminum oxide or something like this. And this can give you significantly increases in strength and stiffness. But I think this is a little bit too far-fetched right now. Probably ask me in 5 years.
So when riders or teams come to you, then what is their reason for coming to you? What are they looking for? Is it simply to save weight? Is it the most aerodynamic parts? What is the attraction to the 3D printing?
Okay. Let's think of it back on what. I mean, the kind of game that I am in, it is how can you make the rider arrive to the finish line faster? Okay. So to do this, it is not a single factor. It is not only weight or only aerodynamics or one factor. It's always a combination of factors. So it has to be reasonably light. It has to be good in aerodynamics. It has to be strong and stiff enough. And most importantly, it has to take you from the start line to the finish line, because it doesn't matter how light and narrow it may be if it falls apart on the way there. So finding the right combination is actually the important bit. And this is where I think we're doing a good job, as in make it aero, light and stiff and usable. And you don't discount usability. There are plenty of examples in the past. If you look in the mid-90s, with a number of bikes, they were like people that were pushing the envelope a little bit too far. They were very aero, but they were either very hard to ride, or you were having like a minor problem with something, and then there were no spare parts and so on. So it is always a combination. By far, the most important bit is you have to have the right balance of all these properties. Most of the times, people, they say, I want it more aerodynamic or I want it lighter. But I always manage to prove to them that the best performance is actually a combination of all these factors. Because we want it or not, perhaps with the exception of track racing, perhaps with the exception of the hour record, I would say, almost anything else, aerodynamics is important, but weight is also important. Because even on a race that it will be like, 180 kilometers of a race, you will have some critical points that they will be very steep, which weight is important. But also you will have a fair few kilometers that will take you to that steep bit. So if you're riding a bike which is very light but not very aero, then you will arrive to that critical point a bit more tired, comparing to if you had an aero bike. So, but of course, if you have a bike which is the single point of its existence is just to be aerodynamic, then when you're going to try to take it up the mountain, if it is 10 kilos, you're carrying a few kilos up the mountain. So it's the combination that matters. So usually people they're coming to me with ideas of I want it more aero or I want it more lighter and so on. And I always try to steer them towards the direction you need to have like a good combination. And to be fair, the vast majority of people, they do understand that, okay, this is the way to go. Every now and then you have somebody who only wants one thing. Yeah, okay, if you want one thing, I'll make it for you.
That's interesting. And so we've talked a bit about bars, but there's no limit surely to 3D printing? Are there frames that are being 3D printed at the moment and other parts?
To my knowledge, there are no complete frames that they are 3D printed. The main reason is cost. Of course, you can do it. And to give you an idea, we're planning to do something like this, but I think the cost, it will be pretty high. And purely because, to give you an idea, these machines, the cheap ones are around £500,000. The cheap small ones are £500,000. And then the bigger you go, £1 million plus is very easy. And if you go to the really massive ones, we're talking about 2 million plus. So to make, for argument's sake, a frame in a single piece, I don't think there is a machine that it can do it today. So then you need to break it down. And then when you start breaking it down, you can fit it on a smaller machine, but then you have to either weld it or bond it together and so on. So although technically is possible, and we are actually planning to do it, but we're planning to do it more for demo purposes rather than anything else. Other than that, to be fair, doing a whole frame in 3D printing, it will probably take a bit of time before it's going to happen. And I was about to say, if you ask me, can you make a 3D printed frame lighter or stiffer or anything like this on a carbon today? I would say no, but I proved myself wrong in the case with the handlebars. And I proved myself wrong that, yes, you can actually do it to be lighter and just as stiff and pass the same requirements in terms of strength. So, yeah. Maybe it is. No, ask me in 2 years' time.
Well, this is what I was going to get onto. I mean, sort of my final real question. I mean, you've mentioned it a few times. Every now and again, you take a period of sort of crystal ball gazing and looking where things are going to go, and sort of give you an opportunity to do that now. Okay. I mean, personally, I'm guessing as this technology scales up and gets cheaper, then things become more possible. We could all have individually printed bikes. The process of buying a bike might be the case that you don't go to a shop anymore or just order stock frame. Maybe go to a place, you get measured, and it prints it out for you. But for you, I mean, a year, 2 years in the future, 5, 10 years, what are you seeing?
I can tell you now that in a year's time, we will be able to make a complete frame, no problem. We actually do for some customers, sorry, I can't tell you who, but we're already making for some customers, probably 50% of the frame and fork. So we are halfway there. And again, it is not so much that it cannot be done, it's actually the cost aspect that it actually slows it down right now. So I think in about a year's time, we're going to do it just like we're going to do it. It's going to be a nice exercise, and I don't know, maybe we sell a few, but it's not going to be that you're going to make thousands of those. It will probably be, I would say, somewhere between the 4 and 5 years' time before you're going to see it to the point where the handlebars are today. Like we're doing the handlebars today, we made more than 100 handlebars so far. And we made the very first one. The very first one we designed, we didn't make it. It was the one that Bradley Wiggins he used for the hour record. And if you think about that, was early 2015. Now we are 2020, 5 years later. And the top-end guys, they have this. In terms of the mass market, we've done very, very few of those. So I think probably within the next 2 or 3 years, we will have like a frame out there. We may be the first, maybe somebody else may be the first, but mind it, at the end of the day, there are other good people working on this. But to come down to the mass market, that's an interesting question. I was just in a conversation with some guys. They're doing some special software just last week, actually. And they have this special software that it can do pretty much what you say, that you can scan somebody and it can automatically fit the bits in between. So you are almost like it fills the gaps in between to a predetermined formula. So it creates the shape that you want. And then you can also apply onto this one some rules on how it needs to be for aero and for structural purpose and so on. And it comes out on the other end, something which is pretty much ready to print. Not quite. I think we're going to arrive at that stage in about 4 or 5 years' time. Wow. But we're going to start experimenting with this within the next year or so.
The Cycling Podcast is supported by Science in Sport. Science in Sport. Fueled by science.
Thanks as ever to Science in Sport for sponsoring the Cycling Podcast and Service Course and a lot of the other things that we do here. If you want to get 25% off your next order with Science in Sport, which of course you do, especially seeing as they have that range just dedicated to indoor training, which we're all going to be doing a lot of as it gets towards winter in the Northern Hemisphere, just enter the offer code SISCP25. Go to scienceinsport.com and enter the offer code SISCP25. Lizzy, you do a bit of moonlighting with Team GB. 3D printed handlebars for you.
Well, I don't know. Who knows? Maybe if I get selected for the Olympics, then we'll do an upgrade your bars session, and we can get Dimitris on board and see if we can make some snazzy bars. But yeah, it was so interesting listening to him. And there are at the top of the show, you heard Ian talking about bars, and over on the Main Top podcast, he was talking a little bit about some of the regulations surrounding handlebars, and it is quite tightly controlled by the UCI. And this has really been a development over, quite a number of years, because what happens with the UCI is that the riders push the boundaries and then the UCI push back. And so there is a rule that says from the middle point of the armrest to the top of the extension, and if you have a mechanical extension with a shifter, then you have to put that into the highest position, and then that is counted as the top point of the extension bars. So the vertical height between those can only be a maximum of 10 centimetres. So quite a few years back, the Tanfield brothers and the Hoob Wattbike guys, who we featured back in February or March, actually. You should go back and listen to that one if you haven't already, because it was a really great episode.
It's a great episode, that one.
They decided, okay, right, there's this rule. We're going to get around this and increase that height between the middle of your pad and the top of the extension by just putting loads of extra foam on the pads. And the UCI said, oh, no, you can't do this. And they said, well, there's no rule to say you can't. So when they put their arms on, the foam pad would squish down, and then they would have a much greater distance than 10 centimetres between actually where their arms were resting on the top of the extensions. So then the UCI changed their rules. They said you can only have one piece of foam, and actually, strictly speaking, the rules say that the vertical distance doesn't include the foam. So, so that's a rule. Then the other rule is that the maximum angle of your extensions can only be 15 degrees. So, I mean, all of these things, I don't really know why the 15 degree rule is applied. But yeah, it's one of those things. So Ganna gets around this by, you should Google his bike, because his extensions are crazy, and his arms almost rest on the extension bars themselves, and the bottom of his base bar is curved downwards, so that when he's on the sides on the base bar, you're much, much lower. So the lower you are, the faster you'll go, because the lower your drag's going to be, basically, when kind of. And then, when he's up in his extensions and his skis, he's kind of half resting his arms on his elbows aren't resting on the pads. It's actually the middle of his forearm that are resting on the pads. And that's something that's really, really challenging. You have to train that a lot to be able to hold that position. But it's a pretty cool position.
It's interesting. I mean, I don't think I've ever been more interested in time trials than I am now, and I'm not sure what it is. I think
it was the 2020 Tour de France that's probably got you and everybody else interested in time trialing.
You might be right, but I also think there's something about the way Rowan Dennis and Ganna rode at the Giro, not just in the time trials, but in support of the other riders. I just found them a bit of a joy to watch, and. I thoroughly enjoyed just watching them, and Ganna is so good, so talented. I just find it one, and his position, his bike, and it obviously says a lot about Ineos that they can keep these riders happy, because we know what it's like when a time trial specialist is at a team whose equipment is substandard. They are not happy.
No, absolutely. And I was thinking actually whilst watching the Giro that it's been really nice to see how happy Rowan Dennis is. And he's performing so well now that he's happy. And when he was back with Bahrain Merida, he wasn't performing. He didn't want to perform. Mentally, he wasn't in the right headspace to be able to perform because he knew that his equipment wasn't up to scratch. And if you have a good team environment, you believe in your equipment, you'll know that your team believes in you and your team is investing in you, then that makes such a difference to your performance. And yeah, time trialling is such a pure sport. I mean, it can be sometimes a little bit boring to watch, but I mean, this year has probably bucked the trend in terms of how interesting time trials are. But it's such a beautiful discipline to perform in. It's just so pure. It's just you and the road and a world of pain. And I love it. I mean, I'm not particularly good at it. It's something that I want to work on and get better at. And it's really about practice, about aerodynamics and about raw power. And you've just got to put those things together, work really hard on them and and chip away at it. And hopefully you'll get there in the end.
Well, let's move on. We've talked about, we've talked a lot about 3D printed bikes and bars, but let's talk about 3D printed helmets.
Yeah, so I got in touch with Hexr because a friend of mine from university, actually, he went straight from university into 3D printing. So I messaged him about a month back and I said, look, we're doing an episode on 3D printing. Do you know anybody really cool? And he said, well, actually, I used to work for Hexr. And that was so interesting because I'd seen the brand Hexr, but I didn't actually know that they made 3D printed helmets. So then I started looking into them a bit more. And what they're doing is so cool. They're the only company doing it. So I got in touch with James Cook, who is the CEO and founder, and he told me all about how this was actually his university, I think maybe his master's project to create this helmet. And then he went and took this and raised enough money to start the business. And now has this really great brand creating 3D printed helmets, custom fitted to you. You use, you order the helmet and then they send you a skull cap, which you download an app and then you just take a video of the skull cap, then send it to them. And then a few weeks later, they send you a 3D printed helmet. So yeah, I got in touch with James Cook and asked him all about his 3D printed helmets.
Basically, the story is that I was doing my undergraduate degree at UCL and had this sort of opportunity to do a third-year project on bicycle helmets and 3D printing. So that's sort of where it started. And then I went to Oxford for 3 years and researched, particularly around energy absorption and trying to select the right type of material and structure. And landed on honeycomb because it has the highest cross strength to weight ratio. And whilst I was doing the research, because it was 3D printing, it sort of felt natural to explore custom fit and see if we can, create a helmet that was also like the world's first custom fit helmet, alongside being a safer helmet. And Henry was helping on lots of different things, but particularly around the sort of technology of getting a custom fit working. So we spun the company out from Oxford, 2.5 years ago. And then in that time, we've brought that first helmet to market. We've shipped maybe over 1,000 of these custom fit helmets. And more recently, we've just developed the smartphone scanning capability. So you can now download an app and just do that sort of 3D scan on a smartphone. And I think what's interesting about Hexr as a company is that we've, really been focused around material science and technology. And I think what's exciting now is that we're seeing lots of opportunities to license the technology to other helmet brands and not just be a single direct-to-consumer business.
So did you actually create a helmet for your university project, or was it the idea and then you didn't have the technology to create it during the university project? Or?
Well, yeah, in the first year, I had no money to develop anything or design a test rig, so I was sort of like going around university, beg borrowing and sort of stealing whatever I could to build a test rig, get some sort of honeycomb samples made. And I remember when I first saw 3D printing, I sort of fell in love with that manufacturing technique, and it was a huge hype like in 2012. And I think when you realise that you can make whatever you want and like there's sort of no boundaries, your imagination starts to wander and explore loads of different types of concepts. So yeah, it was fun. And in that first year, I made, I think, a very small helmet because it was so expensive to 3D print. I think each one was like £1,000 to 3D print. So it was crazy expensive.
Was that because you didn't have your own printer then, and you were having to kind of outsource it to someone else, and they were charging you each time, or is it the design costs, and what is it that's so expensive?
Yeah, it's actually just the material cost that goes into these machines.
Right.
And also the machines themselves are really expensive. So, yeah, it was just sort of, it's designed really for rapid prototyping. So that whole market is, it's just like still very premium, and you can't really compete with injection molding for sort of big volume items, and a helmet would definitely be a big volume item. But, nonetheless, it still felt like a really exciting sort of space to be exploring. When you go into a normal bicycle shop, every helmet is literally exactly the same, big lump of foam, and it's difficult to understand which helmet's going to fit your head correctly. So I felt like we were solving two sort of fundamental problems in head protection, and and I just sort of felt like it was a really interesting research project. And during my time at UCL and that final year, I received the Smart Grant Award. I don't know how I won that, but that was, $15,000, which I then took to Oxford to go and do the research there. And then whilst at Oxford, I raised, I think, £60,000. I then spun my company out from Oxford. And since then, we've actually raised, around £3 million. But we've been developing a lot of, all of that money's really gone into R&D and developing the sort of fundamental technologies behind it in terms of smartphone scanning. We actually have the most accurate smartphone scanning now. And we also have other systems which I can't talk about, which will be hopefully licensed to some of the biggest brands in the next sort of month or two for a product release in about 2 years' time. So
how do you manage to get the same safety structure or the same safety standards as a kind of traditional helmet? Yeah.
Yeah, so a lot of research went into the type of material we're using and the type of structures, which theoretically have about 67% more energy absorption efficiency than foam material, because foam was actually designed for flat surfaces, and honeycomb is particularly effective on curved surfaces, and all of our head shapes are curved. So you've got that piece there, and then essentially we have a very stringent sort of quality control process. So each helmet is checked after manufacture and is manufactured in a particular way to ensure that it's consistent, and then it's sent to the customer. And we have to do hundreds and hundreds of tests beforehand to prove that the safety of the helmet is well below the certification standard.
So we actually looked into kind of certification standards of helmets a little bit in a couple of episodes ago, and I learned a lot about kind of direct impacts and rotational impacts, and that when you're looking at concussion, which is obviously a pretty big thing in cycling and especially in professional cycling, you're looking at rotational impact. And actually the safety standards, well, there is no one safety standard for everybody. Actually, there's different safety standards for Europe, for the US, for Australia, but they don't actually have a test for, or they don't have something that you have to pass for rotational impacts, which are the main drivers of concussion. But I think when I was doing my research about you guys have kind of looked into that, and your structure is pretty good at preventing or absorbing impact in rotational impacts. Is that right?
Yes, well, it sounds like you've done your homework, because it's quite complicated, all these certifications, and you're right, different standards in different countries, and also really crucially important, it's not just linear impacts that are important. There's rotational motion to the head, and that isn't captured in the current certifications, but is likely to change in the next sort of 5 years. So, what our helmets do is that they pass certification, which is the linear impact testing, but they also go beyond that, and we've done lots of testing with a guy called Professor Remy Willinger, who is one of the leading experts in helmet design and head injury, and he's published over 100 papers in this field, and a lot of his work goes into the design of the MIPS certification. So there's a standard called, I think, TEC that MIPS use, and so do University of Strasbourg, which is where Professor Ron Willinger's based. And in these tests, they measure the rotational acceleration and the rotational velocity going to your head, which are two really key components that are not measured as part of the current certification. And we found that Hexr actually performed better than any other helmet on the market, and significantly better than any other helmet on the market. And this includes the MIPS technology as well. And the reason why is because the honeycomb is very good at shearing, which foam unfortunately isn't good at shearing to absorb that rotational force. But also the shell is able to eject, and when that shell ejects, it creates a slipping effect, so the honeycomb can actually sort of carry on sliding rather than getting twisted. Just
for the listeners, I think it's important to make it clear that the helmet is actually made up of two parts. So there's the kind of the 3D printed hexagonal structure, which is the main safety core around your head, and then on top of that there's a molded lid, you might call it. Is that how I'd...
Yeah, exactly. So we have 6 different shell sizes.
Shells.
So outer thin shells, yeah. And on the inside is this honeycomb lattice that's completely custom fitted to your head shape.
So it's the shell that shears away from the lattice, and that helps to take some of the rotational force. And it's kind of like it's like a MIPS, but on the outside rather than the inside when you're describing it, because MIPS is essentially a layer on the inside of the helmet that aims to shear from the helmet and reduce those rotational forces. And actually, it sounds like what's happening here is that the shell on your helmet is doing a similar thing, and it's shearing and trying to reduce those rotational shearing forces, but on the outside of the helmet rather than the inside, which to me actually, when you're thinking about it, seems like it would have a more beneficial effect. Who knows without testing? But I can definitely see how that would work.
Yeah, and I think just on record, we see our technology as being fundamentally different to MIPS, and also ours is patented as well. But the MIPS technology relies on elastomeric material and basically only moves about 5 to 10 millimeters on impact. And actually what we see is that during these oblique impacts, so sort of rotational motion impacts, the head actually is impacted for a longer time and causes more movement than just as 5 or 10 millimeters. So our shell, the fact that it can eject, which is fundamentally different to just slipping and sliding, allows for much more much less rotation to the brain, and it's just shown in the results. I mean, if you look at the results, which are on our website, it's something like a 35% improvement, reduction in the level of likelihood of concussion, which is absolutely huge.
Yeah, I mean, I have to say from a user point of view, from somebody who's used a lot of different helmets and also smashed their head against the floor quite a lot of times, it is something that I always did think about MIPS, that, I mean, I'll do anything I can to try and protect my head in a crash, but how much is it actually going to help? Because it can't move. If you look at the design of a MIPS liner, it can't actually move that much. It's not like the helmet can kind of come apart and it can shear away from that. But I really see how a shell like the one on the Hexr lid could kind of dissipate the energy and the impact a lot more than something like a MIPS liner.
Yeah, and I think if you there's a thing called Folksam, which
I spoke. So two episodes ago, we spoke to Helena Stigson from Folksam.
Perfect. Well, so Folksam has been brilliant in actually publishing the data of helmets subjected to this type of oblique impact. Because currently MIPS don't share any of this test data with the public. And it's a sort of trust that we have in MIPS, that MIPS will internally certify the products to being, I think it's a 10% improvement, but there's a certain threshold. And, what we've found when looking at the Folksam test data is that a lot of helmets that don't actually have the MIPS technology are performing better than helmets that do have the MIPS technology. And on average, MIPS does make an improvement, which is somewhere between 10 to 20%, which is a brilliant thing. And for that reason, we would always be a proponent of using MIPS technology. But I think when you really look at the data, it's not like a significant improvement. Whereas what Hexr helmet is currently doing is a significant improvement. And the work that we continue to do is really trying to push the boundaries of what's possible.
That is super interesting and all sounds great. So my next question. When I was having a little rummage through your website, I spotted in the back of one of the images an aero helmet. And so I couldn't find it on your shop site, but it caught my interest, and it was in a pretty similar design to actually what British Cycling use for their UK SI helmets. And anyway, so I wanted to ask you about that. And is that something you do as just a custom one-off, or was that another passion project, or is that something that you actually put out to the consumers as well?
Yeah, so we were really fortunate that British Cycling essentially came to us maybe like a year and a bit ago to design them their next generation sort of track helmet that was custom.
So it was the one I thought it was.
Yeah, and essentially we are we've been working with them, and we continue to work with them to design better equipment. And I can't confirm, but there's a hope that those helmets will appear somewhat next year.
That's pretty exciting. So are they available? I mean, is one able to buy a custom fitted aero lid from you if one so wished?
Yeah, there is a possibility to purchase, and at the moment there's a window of purchasing that UCI sort of dictate, and that's sort of what we're following in terms
I
of
was going to say, I mean, the answer to that question has to be yes, otherwise British Cycling wouldn't be able to use the helmets at the Olympics if they wanted to, because I don't know if people know, but, well, you will know, of course, but the people, because there is a rule saying that if something is going to be used at the Olympics, it has to be commercially available a certain amount of time before the Olympics. So it's something that, you have to be able to buy it, because it's, the way to try and make it a level playing field. Well, that is all pretty interesting. What do you think is next in 3D printed in 3D printing? Because, I mean, 3D printed helmets is something I didn't think we'd see. I mean, we've seen 3D printed saddles now. We've been talking about that quite a bit recently. And I guess from somebody who's in the know, where else do you think it can go? Do you think we're going to see 3D printed bikes? Are you going to get to the point where you go into your bike shop, you have a fit, and then somebody just whips up a 3D printed frame? I mean, where can we go with this, or is that just unrealistic?
Well, I'm a big optimist, and I have huge ambitions for 3D printing as a technology. I think it has an incredible opportunity to improve the performance of products from structural perspectives, but also from a custom fit perspective. And for that reason, I think it's really suitable to the world of cycling and sport in general. I think the biggest blockers that we see in 3D printing is just the cost of manufacture. And that's something that, the big partners, and we actually work very closely with a company called EOS, which is one of the major 3D printing manufacturers. And it's essentially a big challenge. We're working with them on how to create these digital factories of the future that can bring the cost of 3D printing down sort of by 10x. And, I think it will definitely happen. But it's just a question of how and, when things, and that we don't know yet.
So 3D printed bikes in the future?
I think they've got a role to play, yeah, and I hope they are the bikes of the future, and I'm sure they can integrate into the bikes of the future. One of the important thing now about Hexr is that we're using sustainable materials, so that the actual material of the honeycomb is made from castor beans, which is a 100% bio-based material, and you can also recycle the helmet. So we've been really taking this seriously as the world sort of deals with environmental change and things. So I think that's a really important part of Hexr, and the fact that we also have a modular design, so the chin straps, the padding, the shell, all replaceable, which means you're not limited to having to throw the product away if something breaks, like a buckle. So that's I think part of Hexr's design philosophy, and we're really excited about our sort of partnerships with other brands potentially in the future.
So will you be riding 3D printed helmets on your new team, Lizzy?
I won't be, no. You just keep digging. You just need to wait 2 more weeks, Tom, and all will become clear. My helmet brand will become clear.
Well, I'm looking forward to that. This has been fascinating, some of my favourite episodes of when we do this show are when we sort of look to a year, 2 years, 10 years down the line, and it's clear that the possibilities of 3D printing are absolutely huge. I spoke earlier on about the idea that you want in the future you might just walk into a booth, have a laser measure you up, and then press a button and it prints you out a bike. But it's not as far fetched as it sounds. There's loads of possibilities.
No, definitely not. I mean, James was telling me about his friend Henry Furness, who is working on a venture to make 3D printed bikes. I couldn't get in touch with Henry, unfortunately, but hopefully we'll get him on another show in the future, because I mean, that's just a bonkers venture. Tom and I were talking about this when we were planning the episode, and we were like, no way, you can't have 3D printed bikes. That's miles away. But it's actually really not that far. So maybe we will have that 3D printed bike made of graphene where everything talks to each other and you've got your instant CDA. And maybe we're not actually as far off with that as we thought. So...
Well, Lizzy, listen, I'm going to let you go because I think you deserve a rest and an off-season. So I'm going to let you go. What are your plans for the next... You are going to take a break then now. I think you've probably got some podcast duty first, haven't you? Yeah,
I'm double podcast day for me today. I'm on the main pod this weekend talking about the Vuelta, which is really exciting. It's kicking off there and, everybody's attacking. So that's my kind of race to watch. And, then I'm just going to go walking for a few days and switch off my phone. So if you do ask me which team I'm going to be joining in the next 2 weeks, then I'm going to ignore you anyway.
One more question there, Lizzy. I mean, in terms of the off-season, I've found this season to be absolutely fascinating in terms of how people have either overtrained, undertrained, how they've managed lockdown and all the different things, depending on what country they're in and the laws there. What does this off-season look like for you? Are you going back to more of a sort of traditional off-season, or are you getting back on the bike sooner, later than normal?
I would say this off-season has been particularly stressful because I've been off the bike for 3 weeks now, and the vast majority of that has been in contract negotiations and trying to work out what I'm doing next year. So for me, it's just really important now that I take the next week. I was planning to have 4 weeks off the bike, so I take the next week just having a mental rest, because although I've had a physical rest over the last 3 weeks, mental rest is something that's incredibly important, because this season has been so mentally exhausting with the coronavirus break. Every single person in the world, I think, has been, touched by coronavirus and affected by it and of course worried by it. And then we went into the season and it was just so back to back. And obviously I was expecting to race Flanders, but then we got the news that the team was folding, and then that we couldn't even attend Flanders because the team didn't have any more money. For me now, I'm just going to take another week of complete mental rest, turn off, all of my social media accounts and not let anybody contact me. And if I feel ready to get back on the bike in a week's time, then I will do that. If I feel like I need another week, then I will take it, because the most important thing is to be mentally fresh and ready to hit the next season, because next year is an Olympic year. It's really important for me. There's a lot of goals outside the Olympics that I want to target as well, and I feel like I'm just really chipping away at some top results. So I'm just going to rest now and get ready to hit my training pretty hard for the next year.
Well, I'm just glad that we get to see you racing a bike next year, Lizzy. I'm thankful for that.
Me too.
And of course, doing podcasts. Lizzy, all the best. I'll speak to you on the other side when we know what team you're racing for.
Thanks, Tom. See you next month.